This is our first video on scientific notation. There will be two of them. In this first one, we'll just talk about how to write scientific notation in standard form, and then how to write any number into scientific notation. So this first example, what we want to notice, we have 5.12 right here times 10 to the negative 3. It is that exponent with the 10 that's going to make all the difference in how we approach this problem. One thing you could remember, if the exponent is negative, your numbers are going to get a lot smaller. So this 5.12 actually has to get smaller. The way that we do this is by moving the decimal. And if it's to a negative 3, then we have to move it 3 spots. So we're going to move it 1, 2, and 3, and that's where our new decimal is going to be. Well, the first time we move the decimal over, you can see that it went in front of the 5, and because these last two moves, there weren't any numbers in there, that's when we're just going to fill in zeros. So the standard form number is 0.00512. You notice this answer only has one decimal, and it's at the beginning there. I will see some students move the decimal over and then still keep the decimal in their answer. So just be careful about that. Alright, this next example, we have 4.5 times 10 to the 4th power. Again, we want to look at the exponent with the 10. If you're doing 10 to the 4th power, you're multiplying a lot of 10s together, which means this number is going to get bigger. And how do we get a 4.5? I'll write it up here, 4.5 to be bigger. Well, that's by moving the decimal to the right. And because it's to the 4th power, we're going to move it to the right 4 spot. So here's 1, that gets us after the 5, and then 2, 3, 4, and then we just have to fill in zeros when we ran out of numbers. So this is going to be 45,000, and that is a comma, not a decimal. So that's taking scientific notation and putting it into standard form. Look at your exponent to see if it's positive or negative to help you know which way to move the decimal. Alright, so if you have a standard number and you want to write it into scientific notation, here we have 42,100. Do you see how it's a bigger number? Bigger numbers like this will have positive exponents. So what we have to do is figure out where is the decimal going to go. Decimal will always go after your first significant number, and that means we can ignore zeros, which I'll talk about in the next example. So your first significant number is this 4. So the decimal has to go after the 4. So it's going to be a 4 point, and then whatever numbers you have left, 2, 1. I don't need to write the 0, 0, times 10 to some power. And so how many times does the decimal move to get from its new spot, the 4.21, to the old spot, or from the old spot to the new spot? Well, however you say it. Either way, we can see it's 1, 2, 3, 4 spots. So it's going to be times 10 to the positive 4. Again, positive exponents will be bigger numbers, negative exponents will be smaller decimal values. Alright, this next example we have to write in scientific notation. So figure out where the decimal should go. It has to go after the first significant number. So you can see I have the decimal here, and then there's a 0. Well, that 0 isn't significant, so it's the 2 that we want to pay attention to. The decimal is going to go after that 2. You're always going to have a number and then a decimal. You can see there's a 4 after the 2, so we'll do 2.4. There's nothing after the 4, so we're done with that. Times 10 to some power, and so how many spaces between our old decimal and our new decimal? We can see it's 1, 2, and because this is a decimal value, decimals will have negative exponents, so to the negative 2 power. And there you go.